In chromatography, the stationary phase is where separation begins. It determines how molecules interact, separate, and whether results can be reproduced at scale.
But all of chromatography, selectivity is the key. You have to match the properties of the actual analytes that you're going to be looking for the stationary phase that you're going to be used to do that separation. You need to have some interaction, but not too much. If there's no interaction, you get no retention. If there's too much interaction, then the stuff just sticks to the surface and never comes out. People think just smaller and smaller particles gives you high performance, but that's not necessarily true. Sometimes you can get higher performance on a larger particle if the chemistry is better. Take an oligo separation and you're going to run it at pH 10, and you have a 5 micron particle that is stable at pH 10, it's going to give you good performance over a long period of time. The performance is also dictated by the packing, how well it's packed, the mechanical stability of it, does it hold up over time? And then you really need to look at the overall lifetime of that application. Is the column reproducible year after year after year? Or do you have to keep changing your method because the surface of the stationary phase changes over time from the manufacturer?
Today's biopharma landscape demands solutions across a wide range of modalities.
We have a stationary phase for the separation of almost any modality, meaning from small molecule pharmaceutical ingredient all the way to viral vector, which is very unique.
The GLP-1 peptide stuff, the Triart reverse phase media really is amazing for it. It's mechanically sound. It's got the pH stability that you can run it just a little bit higher if you want, and it's scalable.
They're fully scalable from analytical scale all the way up to prep. We can make those up to 20 micron particle size. So selectivity stays the same from analytical up to prep, and that mechanical stability allows it to be packed and repacked.
You can develop a process in a small analytical column. For peptide, we have about 12 different stationary phases, and then you have your method developed. And what's amazing, you can scale up from virtually an analytical scale to a larger scale with just a couple of basic equations. Speed to market, it's critical. And of course, API, pharmaceutical ingredient, quality. Quality is a given, and performance of the stationary phase is critical, and that we have.
Different separations require different mechanisms.
Ion exchange is unique because it's truly an electrostatic type of interaction. So you can almost think of it as magnets. So on the surface of an ion exchange media, they have immobilized one of the charges. And as the analytes are flowing through, if there is a positive charge on the surface, a negative charge floating along will stick momentarily to the positive charge. And that's the interaction that we're looking for in ion exchange. The way we get those to stick and then release and move on is we either change the pH a little bit, or we increase the ionic strength of the solution by adding salts. Size exclusion is more of a filtering. Large analytes don't go into all the little pores, so they actually elute first. And then the smaller analytes go deeper into the pores, and they take a little longer for the flow path so that they come out later. And then the really small ones go all the way through all the little pores, and they come out last. You don't want surface chemistry going on between your analyte and the stationary phase or the hardware, because that will retain the things. So you want the things to go through purely on a size aspect. So YMC offers size exclusion chromatography with a polymer hardware, and it also has a stainless steel hardware that's been coated that takes away the metal interactions to make it more inert.
YMC's built their reputation on reproducibility, excellent reliability there. Sometimes customers come to us with lot-to-lot issues and ask us if there's any recommendations for a column that would be almost a direct replacement for the column that they're currently using. And they get that YMC reliability. We have a broad background of scientific capability, as well as our own application scientists that are devoted strictly to application development and lab services. And we have two working labs, our Insight Center labs, one out in Thousand Oaks, California, and then the other one at our Devens facility in Massachusetts. So we have a lot of technical capability there for making recommendations, helping troubleshoot, doing column screenings in-house. Customers can send us a sample and we can do column screening for them.
YMC America is small enough that we can be partners with companies. Technically, my entire job is to work with customers, to be that technical person to talk to people on a science-to-science perspective.
At the center of every separation is the right interaction, controlled, reproducible, and scalable. Find out more on ymcamerica.com.